When it comes to factoring trinomials, some people have a problem when there's a coefficient in front of that first term, like 12 in front of the x squared. And so I'm going to take two that look very much alike here and show you how it isn't as much of a guessing game as what some people think it is. If you look at 12x squared, you've got the factors of 1 and 12, 2 and 6, and 3 and 4. If you look at the factors of 20, you have 1 and 20, 2 and 10, and 4 and 5. All right, now my first step of factoring is always take out your greatest common factor. If you look at 12, 1, and 20, the greatest common factor is 1. So we don't necessarily have to take out the 1. Okay, if it's anything bigger than 1, we would take it out. So there isn't a greatest common factor. So look at your quantities here. If you were to choose the 2 and the 6, they are both even. And no matter which of the ones you choose for the 20, like 4 and 5, or 2 and 10, or 1 and 20, no matter which of those you choose, you are guaranteed to have to put an even number with an even number. Okay? So you know 2 and 6 cannot be the factors that you want. And you also know that 2 and 10 cannot be the factors you want because they're both even. And no matter what you put together with them, you will get an even with an even. And that can't happen because if that were to happen, if you were to go with 2 and 4, that means there would have been a 2 in common. And there wasn't a 2 in common. So we know right away that 2 and 6 and 2 and 10 cannot be the factors that we're going to use. So go back, and for 12, you have choices. You have 3 and 4 or 1 and 12. When you look at this middle coefficient, the middle coefficient is a 1. All right. My rule of thumb is if that middle coefficient is small, then you want to pick numbers that are close to each other. If that middle number is large, you want to pick numbers that are far apart from each other. Well, since that is a 1, we are going to pick factors that are close to each other. So I am going to pick 3x and 4x. I'm also, for the 20, going to pick factors that are close to each other. So I'm going to choose the 4 and the 5. Now, again, I know that I cannot put the 4 with the 4 because if I did, there would be a common factor. So I can't put the 4 with the 4. I have to put the 5 with the 4 and the 4 with the 3. And in order to get a y squared, I've got to go 4y and 5y. Now to get that middle term, you look underneath the inner and the outer. The inner is giving me my 16xy. The outer is giving me my 15xy. Can they differ by 1? Well, yes, they can. I need a negative 1xy. The only way I can get a negative 1 is if I have a negative 16 with a positive 15. So I'm going to put my plus with the 5 to make that a positive 15, and I'm going to put my negative with the 4 to make that a negative 16. Okay, now let's look at the next problem. The next problem has the same coefficients in front, the 12x squared, and it has the same coefficients in back, the 20y squared. So I'm still with 3 and 4, 2 and 6, and 1 and 12. And I'm still with 4 and 5, 2 and 10, and 1 and 20. And again, because there isn't a greatest common factor of all three terms, I know I can't use two even numbers because I would have to put an even with an even, and that can't happen because there isn't a greatest common factor. But this time when I look in the middle, I see a large number in the middle. So that means to me that I'm going to try and use numbers that are far apart from each other. Now, it doesn't always work that way, but that's where my guessing starts. If it's a large number in the middle, I'm going to try with the 1 and the 12. I'm also going to try my large numbers for the other side. Okay, so 1 and 20. And again, I know that I cannot put the 20 with the 12 because then there would be a number in common. So I'm going to put the 1 with the 12 and the 20 with the 1. And now I see I have 240 and I have 1. Well, that is not going to give me a 77. So, okay, that didn't work. So I have to change one of them. And I don't really know which one I'm going to change. So at that point, I'm guessing. Okay, so I'm going to guess to change the 20. If I change it to 4 and 5, which is my only other choice for 20, I cannot put the 4 with the 12 because then there would be a 4 in common. So I would have to put the 5 with the 12 and the 4 with the 1. And I get a 48 and a 5, which does not give me 77. So I guessed wrong. I didn't want to change the 20. I wanted to change the 12. So I'm going to go back and put my 1 and 20 down, and I'm going to change my 12. Again, I do not have very many choices. I have to choose the 3 and the 4, and I cannot put the 4 with the 20 because then there would be something common. So I have to put the 3 with the 20 and the 4 with the 1. Now, to get a 12x squared, it has to be 4x and 3x. To get a 20y squared, it has to be 1y and 20y. And then we check underneath. Here's a 3xy. Here's an 80xy. Can I get those to differ by 77? You bet. If I have a negative 80 and a positive 3, I will get a negative 77xy. So my negative is going to go with the 20 and my positive is going to go with the 3. So that is my little hint about factoring. When you look at the coefficients, you cannot put numbers that have anything common together unless there was a greatest common factor. But of course, we take that out first.